The functions f and g are defined for x an element of R as f such that x maps onto 2x squared minus 3x plus 2 and g such that x maps onto x squared plus x plus 7. Find the coordinates of the 2 points where the curves y equals f of x and y equals g of x intersect. So what we notice is that at the points of intersection of the two curves, f of x is equal to g of x. So like x is this value here that we're looking for, and if we f of x is the y value of this point, g of x is also the y value, and they're the same. If we go across here, we just get one value. Normally we get two values, as you can see. If x was say here, we would have two values. We just have one value, and this is not the only value of x. There's a second value of x from this diagram, which is over here somewhere, such that f of x equals g of x. So the key thing is to put f of x equal to g of x, and by solving this we can find the value or values of x for which that's true. So we just have to solve this equation here. We're going to end up with a quadratic because if we bring this over, we're going to get 1x squared minus 4x plus 2 minus 7 is minus 5. Get it into standard form, 0 on one side, the x squared doesn't go out, so that tells us that there are at most two solutions, as you can see from the graph. Factorizing this, if it has factors, let's see what we get. We need minus 5 here and plus 1 here to get minus 4 in the middle. Equating each of these to 0, we get x equals 5 or x equals minus 1. So this value here appears to be minus 1, and this one must be 5. Now we want the coordinates of the 2 points where the curves intersect. So to do that, we need to get f rg of minus 1 and then f rg of 5. So let's get f of minus 1. So we just plug minus 1 in here. So minus 1 squared is plus 1. So we're going to get plus 2. Minus 3 by minus 1 is plus 3. Plus 2. That's 7. And g of minus 1 should give you the same answer. Minus 1 squared is plus 1. Plus minus 1, that'll give you 0 plus 7. Yeah, g of minus 1 is also 7. So that checks out. Let's look at f of 5. Plugging 5 squared is 25 times 2 is 50. Minus 15 is 35 plus 2 is 37. So if we plug 5 in here, we should get the same answer. 5 squared is 25, plus 5 is 30, plus 7 is 37. It does indeed check out. Find the area of the region enclosed between the two curves. Well, if we integrate f from minus 1 to 5, we will get the area underneath f. If we integrate g from minus 1 to 5, we will get the area underneath g between minus 1 and 5. And then if we subtract those areas, we'll be left with the area enclosed between the two curves. So let's get the area under f first. So that's the integral from minus 1 to 5, because we're integrating between the vertical lines of minus 1 and 5. The area underneath the graph of f. So f is 2x squared minus 3x plus 2. So we integrate this with respect to x. If we do that, we have to add 1 onto the power and so on. It might be easier actually to subtract. We have to do that for f, and then we have to do the same for g, and then we have to subtract the two results. Actually, an easier way of doing this is to get the area under f and subtract the area under g. Of course, that's what we have to do, but since we're integrating, we will be doing the same integration. We might as well actually just take f and subtract g. So we take the function f and subtract g. That's the same thing as doing two separate integrals. So what I've been trying to say is that the area under f minus the area under g is the same as the area under the function f minus g. So if we take f and subtract g, 2x squared minus 1x squared is 1x squared. Minus 3x minus x is minus 4x. Plus 2 minus 7 is minus 5. This is just a quicker way of doing it. If you do it, you can check it if you do it the other way. You'll get the same. Let's see now. What do we get here? Integrating x squared gives a third x cubed. Integrating minus 4x gives minus 4 over 2, which is 2x squared. Integrating minus 5 gives minus 5x. If you differentiate this, you can check it. This is from minus 1 to 5. So we plug 5 into all of this. We get minus 33 and a third. We plug minus 1 in here. Minus 1 cubed is minus 1. So this is going to become a minus 1/3. We're going to get a minus 2 here. So that's going to give us minus 1 and 2/3. Then plus 5. 5 minus 1 and 2/3 is 3 and 1/3. So we plug the upper limit in, work it out, then put down a minus sign. Then in brackets we work this expression out with the lower limit in for x. So what does this give us? Actually, this should be 2 and 2/3. So we get minus 36 for the answer. So that's the area between two curves. Why did the result come out to be negative? Well, actually, I did this the wrong way around, but it doesn't matter. The answer is 30. The correct answer is 36. The reason it came out negative is because what I should have done was not f minus g, but I should have worked out g minus f. Because g is actually the curve that is above f. I misread this. I thought f was above g, but it's not. G is above f for all values of x between minus 1 and 5. G is greater than f. So g minus f would come out to be positive. G minus f is a positive thing. So what I did was I integrated f minus g. That's what this here is. What I should have done is integrated g minus f. But the only difference between these integrals is that the integral of f minus g is just a negative of the integral of g minus f. So I should have integrated minus x squared plus 4x plus 5 with respect to x. This is what I should have had. That's just got by minusing this expression. But it makes no difference because you can imagine taking the minus sign outside. We can take out a factor of minus 1. It's the same as integrating x squared minus 4x minus 5 with respect to x. So we would have got minus 36, which is plus 36. Well, when you get a negative value for an area, you normally just make it positive anyway.